Welcome to your Year 10 Maths unit on probability. Before we really get started into the new content, let's revise ourselves of probability and chance over our years of schooling. So, in your early years at school, you would have used the words associated with the language of chance. So, you would have said things like, it will happen, it might happen, it won't happen, about different events occurring. So, it will happen that I'll have lunch today. I might have a chocolate when I get home from school. I won't be going to the Maldives today. Okay, so that kind of language you would have used from a very, very young age. Then you would have got a bit more specific using words like it's like something's likely to happen or unlikely to happen. It's certain or impossible, and you would have used those kind of terms. Then you would have moved on to looking at what the chances of something occurring are, and you would have seen a number line very similar to this. When something that's fully certain of occurring, definite, is given a 1, but something that's impossible, definitely not going to happen, is given a 0, then everything else falls on the scale between that. And how do we find those decimal places out of where something falls? We divide our fractions. We'll look at that further on. Okay, so a bit of a maths flash. Do you remember how to change a decimal to a percentage, or a percentage to a fraction, or a fraction to a decimal, or a decimal to a fraction? This is a really cool little triangle that shows you what you have to do. My advice, if you can't remember it, this is the first thing that is going in your bound reference. Okay, converting decimals, percentages and fractions, and then draw that in. Okay, put that illustration into your book by your own hand. Don't copy it like a photo or anything. Write it in. Use colours, make it stand out. Okay, so another maths flash here. These are just some common percentages in their fraction form and in their decimal form. So 50% is the same as half, is the same as 0.5. 33 and a third is a third, or 0.33333, reoccurring. 25% is a quarter, it's the same as 0.25. 20% is 0.2 or a fifth. 12.5% is the same as 0.125, and that's an eighth. And a tenth is 10% and 0.1. So that might be a table that you also want to note into your bound reference, just to have there as something to reflect to. Alrighty, so then you started to bring numbers into probability. And we would have had this thing called a sample space, and it's all the possible outcomes of a trial that you're doing. Now, we're going to look at sample space more as we progress through this unit. We're going to change the wording a bit. But if you are doing an experiment and there's 10 different outcomes, the actual sample space is what those outcomes could be. So if you're throwing a dice, a 6-sided dice 10 times, the sample space is 1, 2, 3, 4, 5 and 6, because they are the possible outcomes. Okay, if you're flipping a coin, your sample space would be 1, 1, 2. Why have I put 1, 2? Should be heads or tails. Okay, I don't know why I've put 1, 2 there. It's probably because of the next thing. But your sample space, you've got 2 elements, 2 options. 1, heads or tails. Where'd my 1 or 2s come from there? Probably from the half, isn't it? Okay, so the chance, the possible outcome of getting a heads is 1 out of 2. And the possible outcome of getting a tails is 1 out of 2. If you divide 1 by 2, you get 0.5. Okay, so there's 50% chance of getting a heads, or 0.5, and that would go on that, your line of certainty, halfway there. All right, well, you would have started looking at probability, and we have these two things called theoretical probability, so what the outcome should be, and then we have our experimental probability, which is what we actually got in our experiment, whatever we're conducting. So let's have a bit more look at theoretical probability. If we're rolling a dice, the chance of rolling a 1 is 1 out of 6. We're looking at a 6-sided dice. I know some of you will say, but what if it was a 10-sided dice? Then our chance would be of rolling a 1 would be 1 out of 10. Okay, chance of rolling a 2 is also 1 out of 6 because we're looking at our 6-sided dice. Chance of rolling a 3 is 1 out of 6. Chance of rolling a 4, 1 out of 6. Chance of rolling a 5, 1 out of 6. Chance of rolling a 6, 1 out of 6. That's theoretical probability. You know that if you sat there and rolled a dice, you wouldn't get one of each because that's then our experimental probability. Alrighty, let's have a look. We've got a colour wheel here with a spinner. And if we was to spin our spinner, what is the probability of it landing on each colour? Now we're going to get a bit more technical. Instead of just writing what's the chance of or what's probability of, we're going to write it like this. Probability, and then in brackets we say the events. So the probability of spinning a red is 2 out of 8. Look, we've got 1, 2, 3, 4, 5, 6, 7, 8 colours, but 2 of them are red. So 2 out of 8 for a red. And we can simplify that to 1/4, so 1 out of 4. The probability of rolling a green is 1 out of 8. There's only 1 green. Orange, 1 out of 8. There's only 1 orange. Blue, 1 out of 8. There's only 1 blue. Grey, 1 out of 8. There's only 1 grey. Pink, 1 out of 8. There's only 1 pink. Yellow, 1 out of 8. There's only 1 yellow. That is the theoretical probability. You know, if we did it as an experiment, we wouldn't get that necessarily until we'd done lots and lots of trials. Alrighty, now we can work out our theoretical probability. So the probability of an event is the number of favourable outcomes divided by the total number of outcomes. Let's think about that in terms of our colour wheel. Okay, so the number of favourable outcomes. So the chance of 2 reds, 1 green, 1 orange, 1 blue, 1 grey, 1 pink, 1 yellow, and the total number of outcomes being our 8. Okay, now if we divide the number of favourable outcomes by the total number of outcomes, we get a decimal value. So for example, our red, 1 divided by 4 gives us 0.25. For all our other colours, 1 divided by 8 gives us 0.125. That then relates to our number line here. So 0.25, it's unlikely that we'd get a red. It's even less likely that we'd get one of the other colours. Wonder how that would change if we had 1 whole half that was blue. Alright, so that's our theoretical probability. Our experimental probability is what the outcomes actually were. If we had that spinning wheel and we sat there 20 times spinning it, what would the outcomes be? And we can work our experimental probability out the same. The number of times we got a red out of the number of outcomes. So if we spun our wheel 20 times, and we got 5 reds, it would be 5 divided by the 20. Okay, we're now going to have a look at this concept of frequency. And what frequency means is how often something happened. And we've got a frequency table here. We're looking at a survey was done by a class of 31 students to see how many times they played sport in the last month. Okay, now I didn't read that because when I actually do this further, I'm looking at these as scores. Okay, so you'll see what I mean. So what is the experimental probability of scoring 3 goals? So I'm thinking this is goals. Okay, so we're just going to roll with this for a minute. Okay, the probability of scoring 3 goals. Remembering this is 3 in my mind. I'm seeing a sports season, and I'm seeing these are the number of goals that have been scored. Now, 31 students, okay, so we had 6 scored 3 goals. So 6 out of 31 scored 3 goals. All right, what have we got here? Scoring less than 4. Okay, so we've got our 4 is there. What are we going to do for this less than 4? So we're going to add up everything that is less than 4. So we've got 4, a 6 and a 9. So 6, 9, 4, add them up. So 19 out of 31 scored less than 4. Okay, 4 or above. What are we doing here? Sorry, my transitions keep changing. All right, so 4 and above, we've got 7, we've got 3 and 2. So we add them together, that's 12 out of 31. All right, so some of the key terms in our probability work that we've done in the past, we've got this whole idea of trials. So the different trials that we do in an experiment. We've got our sample space, so the number of possible outcomes or the possible outcomes that we could get. The actual outcomes, what we actually got. The event, so the probability of something happening. So the event in terms of heads and tails could be a head, so the probability of getting a head. Equally likely outcomes, chance, theoretical and experimental probability, and frequency. So they're just some key terms that we need to have just in our mind before we move on to our next unit. So you had a couple of things there to get into your bound reference, okay, especially that converting from percentage to fractions, fractions to percentages, decimals, percentage, okay, so that triangle and those common percentages and fraction and decimal form. Also having in mind that number line, so where 1 is certain and 0 is impossible, having that in your mind. Thank you for watching. I'll see you in the next video.